Okay, welcome everybody. Sorry we're a few minutes late getting started. We're just going to give it a few seconds here as there's folks signing in. Yeah, I think we're ready to go. Okay, so I'll get things started. We don't have a whole lot of time and a lot of information to cover. So I will start things off and then we'll hand it over to the meat and potatoes of the webinar. So good afternoon. Thank you all for joining us for today's session on the wind energy supply chain in Atlantic Canada. My name is Amanda White. I'm the Senior Director of Operations and Member Services at Marine Renewables Canada. We have many members online with us today, but for those who aren't, Marine Renewables Canada is the national industry association for tidal, offshore wind, wave, and river current energy. Core part of our mandate is to support and facilitate development of the Canadian supply chain for marine renewables. So before we get started, I want to take a moment to recognize and acknowledge the traditional territories and Indigenous peoples of the different lands that we are all on today. I'm hosting this webinar from Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. Given that we are coming together today to discuss onshore and offshore wind, I also invite all of us to think about the impacts that renewable energy projects can have on Indigenous communities and how we can improve our own understanding of local Indigenous peoples and their cultures to ensure that marine renewable energy projects move forward inclusively and respectfully. I'm also just going to go over a few brief housekeeping notes. We are recording this webinar, excuse me, and it will be posted on the MRC website afterwards. The bulk of today's webinar will be a presentation, which will be followed by a question period. So the intention behind this webinar is to really respond to your questions, so I encourage you to ask them. You can use the chat or the Q&A function for questions, and we'll do our best to get to all of them today. The purpose of today's session is to share the results of the Atlantic Canada Wind Energy Supply Chain Assessment. As many of you are already aware, there's a lot of activity underway in Atlantic Canada when it comes to wind energy. There's an increasing focus on developing both offshore and onshore wind resources to help green the grid and pursue green hydrogen opportunities. Developing these renewable energy resources presents significant trade and supply chain opportunities by leveraging local supplier expertise to service projects. And when it comes to offshore wind, suppliers who have relevant capabilities from working in offshore and marine industries have directly transferable skills that can support future offshore wind development. At the same time, the level of wind energy development in the region can create challenges. There may be supply chain gaps, challenges, meeting demand with existing capacity, and skilled labor shortages. Critical component of ensuring sustainable growth of the sector is to have a strong, robust supply chain and workforce to support project demand. And that's where this project plays an important role. MRC commissioned Xodus Group and a team of local industry advisors to lead a wind energy supply chain assessment on both offshore and onshore for the region to help support an overall goal of developing a Canadian offshore wind supply chain and further growing capacity in the onshore wind supply chain to support growth. This work was made possible through funding from several government partners, including the Atlantic Canada Opportunities Agency, Nova Scotia Department of Energy, and Prince Edward Island Energy Corporation. Given the importance of this project for the region, we wanted to ensure that local suppliers could learn more about future opportunities in the region's wind energy supply chain and gain insight on how to get more involved. So today you'll be hearing about the results of the final report, including supply chain strengths, challenges, and overall recommendations to build a strong local wind energy supply chain. I'd like to introduce you to Delia Warren, lead renewables consultant with the Xodus Group, and Grace Catherine, energy systems engineer with Angler Solutions. They will provide a presentation on the results of the supply chain assessment. So as I mentioned, there'll be an opportunity for you to ask questions at the end of the presentation. So feel free to use the Q&A function during the presentation as they pop up. So Delia, I'll hand that over to you.
Thanks so much, Amanda. And thanks everybody for signing on today. We are going to be going through a lot of information. So everybody get ready for that. Okay, I'm going to go ahead and share my screen. Right, just give that a minute to load. All right. So, as mentioned, we will be presenting the results of the Atlantic Canada Wind Energy Supply Chain Assessment. I am Delia Warren, a lead renewables consultant with Xodus Group. So before we get started, I'll just give you a little bit of background on Xodus and what we do. We have offices all over the world, as you can see here, and we work in the energy industry, both traditional fossil fuels and renewable energy, focusing on bankability, buildability, and permitting, so commercial, technical, and environmental. I sit on the industry development team in Boston, where we focus pretty exclusively on offshore wind, at least for now. And we started an early industry phase doing things like assessing supply chain, workforce, economic benefits, doing stakeholder and rights holder engagement, that kind of thing. So we've done supply chain studies in at least 10 states to date for offshore wind, but this is our first time working on an onshore wind supply chain study. So we've got some partners along. So to get started, we'll go over the project. I'll introduce the project partners. Then I'm going to hand it over to Grace to give an industry overview. Not sure if everybody on the call is as familiar with offshore and onshore wind energy as we are, so just to get everybody on the same page. Then I'll go through the details of the supply chain assessment and the outcomes and results. Grace will give the results of our opportunity assessment. Then I'll present all 25 recommendations and just summarize the scope of the study. And we'll have some time at the end for questions. So just pop them in that Q&A. Okay, so just to give some background on the project, we've been working on this scope since late summer, and we looked at the offshore and onshore wind supply chains of Atlantic Canada, including Newfoundland and Labrador, Nova Scotia, Prince Edward Island, and New Brunswick. So the objectives here are to understand the current supply chain capabilities, including strengths and gaps, analyze industry requirements and timelines, identify investment opportunities for both the public and private sector, and both locally and internationally, to build awareness of partnership opportunities, understand workforce requirements, and ultimately to develop actionable recommendations that will maximize economic benefits to Atlantic Canada and ensure a sustainable and inclusive wind energy supply chain. So you can see on the top right here, these were our project partners. In Newfoundland and Labrador, we had Envigour Solutions and Karen Hocko Group. In Nova Scotia, we had Envigour Policy Consulting, Roxham Advisory and Consulting Services was out of New Brunswick, and Eric Christmas was acting as our Indigenous liaison on this project. So we had a great geographic distribution and distribution of expertise here, which allowed us to come up with some really great recommendations in the end. Okay, so I'm going to hand it over to Grace for the industry overview. And Grace, you just tell me when you need me to change slides.
Perfect. Thanks, Delia. It is a pleasure to present a couple of slides here from the study that we've assessed for about 8 to 9 months. Just a quick background to the wind industry. It started in early 1980s with the first large-scale wind turbines were built on land, or we call it onshore. This came after the 1970s oil crisis, which pushed countries like Denmark, the US, and Germany to find alternative energy sources. Offshore wind came much later, like 10 years later, and the first offshore wind farm in the world was in Denmark, installed in early 1990s. So here in this slide, we see there is two types of wind industry. So wind industry generally divided into offshore and onshore, mainly because the environment where the turbines are installed creates a very different conditions, and that leads to different challenges, costs, technologies, and opportunities. One of the vital components that makes them different is the foundation. So offshore wind, we separated into fixed and floating. So fixed offshore foundation are physically embedded in seafloor, where floating offshore has a substructure that is tethered to the seabed using mooring line, both chain or synthetic, or anchors, and typically more than 60-meter water depth. Although the levelized cost of wind energy is decreasing over time, offshore wind is more expensive and still logistically complicated than onshore. It has a larger turbine size and larger capacity factors. We talk about 40 to 60% capacity factor for offshore wind and around 25 to 40% for onshore wind. Capacity factor is the energy generated per installed capacity. And those figures are some of the outlook of fixed, floating, and onshore foundations. Next, please. So here in your screen, we have a chart or diagram, cumulative installed capacity in gigawatt against commercial operation date. We are right there in 2025. And as you can see, we have globally has around 100 gigawatt installed capacity for offshore wind. So the blue pale represent Asia Pacific excluding China, the blue color corresponding to China, the greenish yellow, it's Europe, and the purple one correspond to the US. And as we can see, in the next 5 years, which is 2029, the installed capacity in Europe is larger than Asia Pacific and United States combined. Next, please. Here we have offshore wind in Atlantic Canada. So Nova Scotia has a stated goal of leasing 5 gigawatt of offshore wind capacity by 2030. So that's a good news. And amendments to Atlantic Accord Acts have mandated joint federal provincial management of offshore renewables in Nova Scotia and here in Newfoundland and Labrador. So these figures in the center is the regional assessment process carried out in Nova Scotia and Newfoundland and Labrador, and that's to provide information, knowledge, and analysis that will inform future offshore development process. And in the top of your screen, that's the regional assessment in Nova Scotia. We see 5 wind energy areas that were proposed by the Nova Scotia government. It may be too small, but there is a Sydney Bight in the northeast of Nova Scotia, French Bank, Middle Bank, Saddle Island Bank, and Emerald Bank in the eastern side of Nova Scotia. And in the bottom of the figures, we see the regional assessment carried out in Newfoundland and Labrador, and the focus area mainly in the south to southwest part of the island. Unfortunately, New Brunswick and Prince Edward Island have no stated plan to develop offshore, but may consider it if project economics improve. Next, please. Now we see the onshore wind. Can we go back? Yes, perfect. This is the onshore wind still in Atlantic Canada because that's the main objective of this study. We have Nova Scotia, Newfoundland, Labrador, Prince Edward Island, and New Brunswick. And if you have a chance to look at the final report, you can see more clearly. So basically in every provinces, we have that bullet or bubble, which represent the project capacity in megawatt. The smallest one is less than 15 megawatt, and the larger bullets is represent 200 to 350 megawatt. And also you can see the project status, whether they are operating or under development. Atlantic Canada itself has just under 1.3 gigawatt of installed onshore wind capacity. There is a clean energy goals and green hydrogen sustainable fuels, which are primary drivers of wind development in Atlantic Canada today. And we do have a plan for 34.5 gigawatt of onshore wind for green hydrogen production. And those table is quite important. That's represent the installed onshore wind capacity in megawatt, planned additional capacity for grid, and planned capacity for hydrogen. All right. Next slide. This is going to be the last slide of the industry overview. again, if we talk about supply chain, it's a very diverse, robust, and holistic system because it covers the entire life cycle of a wind project, from raw materials to recycling. So it's not just about making turbines, but also about supporting the whole ecosystem. So here are some snapshots of the existing supply chain in Atlantic Canada. We have Atlantic Canada Bulk Terminal in Nova Scotia. If you take a look closer, there are blades there and some monopiles. Also, blade production in Gaspé, Quebec. I know this is not in Atlantic Canada, but that's the closest blade manufacturer that we have. Also, Halifax Harbor, Nova Scotia, and the picture of some monopiles at Port of Argentia. So that's all for the industry overview. I'll give it back to Delia.
Thank you so much, Grace. All right, so as we can see there in that last slide, we've already been participating in the offshore wind supply chain, even if there are no offshore wind projects happening in Canada. And we certainly have a lot of potential in the onshore space with those significant capacities that are being built out. Okay, so now we'll go into the meat of the assessment, and I'll start by describing some of the terminology or taxonomy that we're going to be using. So this is the standard approach that Xodus Group takes when we do our supply chain assessment, and we've adapted the taxonomy to include onshore wind as well. So if you see this table here on the right, this is the supply chain taxonomy, and we start by defining the supply chain area. So we also refer to these as packages, and this is essentially the major contracts or pieces of work that are carried out to build a wind farm. So you start with project development. That includes activities like project management, permitting activities, surveying and environmental monitoring, engineering and design, and they're primarily services that are delivered in the early phases. And you can see in the far column if the supply chain element that I'm describing refers to fixed, floating, onshore, or both. After project development, we've got manufacturing and component supply. WTG refers to wind turbine generator, and BOP refers to balance of plant. So that's all the physical aspects of the wind farm, all the components except for those that are in the wind turbine generator, which include the tower, the nacelle, which houses all the generating equipment, and the rotor and blade. So each turbine here has 3 blades. So these are primarily products, but also considered in this category or this package are the services required to complete these tasks. So major and minor industrial electrical equipment, industrial motion, precision component fabrication, blade supply, major steel component supply, secondary steel that refers to things like handrails, work platforms, lifting frames, that type of thing. Mooring and anchors, cables, ancillary equipment supply. So that would be, equipment that you can rent to get the job done, like cranes and generators, and then vessel design and build. Construction, transportation, installation, and commissioning. That refers to the actual construction of the wind farm and getting it ready for operations and powering the grid or whatever the end use is. Operations and maintenance, this is the longest phase of project development, typically considered about 25 years. And that includes all the operations, the inspection, regular and unplanned maintenance, major component repair, etc. Then following that, we've got decommissioning, which is, it could mean repowering or dismantling the infrastructure and restoring the site. And then finally, we have sector support, which includes government, industry associations, training, labor associations, R&D, and then professional services like finance, insurance, very critical to getting these projects built. Okay, and then in the top left, you can see we've defined some supply chain specific terminology, and we refer to the supply chain using these terms. So I wanted to make sure they were defined for everyone. The developer is the owner and operator of the wind farm. An OEM is responsible for the production of fully assembled major components. So the turbine OEM would be, for instance, Vestas or GE. A tier 1 contractor contracts directly with the project developer. Tier 2 contracts directly with a tier 1 supplier, and a tier 3 contracts directly with a tier 2 supplier. And so on and so forth. But we stop our assessment at the tier 3 level because we find beyond tier 3, companies are typically so general that or the products or services of the companies are general. So it's less easy to, or less valuable to assess, to map them to a supply chain. So basically, we've established all this taxonomy and terminology to match roughly the contracting structures within a offshore onshore wind farm, so that companies that are assessed out to a supply chain element will have a better idea of where they stand within a supply chain. And the way we did this is we assessed a total of 1,070 companies for applicability according to those supply chain elements. And we looked at high, moderate, and low applicability. To do this, we compiled a number of databases from a number of sources in Atlantic Canada, combined them all, and looked at every company's website, press releases, news articles, any publicly available information that we could find. And we were able to categorize them based on high applicability, being direct experience in either offshore or onshore wind, or whether or not they provide products or services that are highly relevant in design, scale, and production volume. We also looked at the investment level that would be required. So for high applicability, investment required to transition the company would be minimal, or would be directly applied to scaling and qualification operations. So these are companies that are really close and just need a little bit of extra investment to get to the supply chain. A moderate applicability company will have no direct experience, but provide products and services that are similar to offshore and onshore wind in design and scale. And here the investment would primarily be used to retool, as well as meeting standards and qualifications and scaling operations. And then lower applicability would be, they provide products or services that resemble those needed in offshore and onshore wind, but would need significantly to change their operations. There would need to be a real drive for them to do that. And then, of course, investment would also be significant to retool. I mentioned qualifications and specifications here. The supply chain for the wind energy industry can be notoriously difficult to break into. And a lot of the companies that operate here have strict IP, or they would require significant, often multi-year onboarding operations that can also be quite costly to companies. So that's why we consider this directly as an investment. All right. So we'll present the results first by offshore wind, and then we'll look at onshore wind. So as you can see here, this graph, this bar chart, it follows the colors that were shown in the table in the previous slide for taxonomy. We've got project development, manufacturing and components design. We've got construction, transportation, installation, and commissioning, operations and maintenance in purple, decommissioning in yellow, and then sector support in orange. And you can see where the bars are the highest. That represents the number of companies that were mapped to that category. And companies were mapped to every category that was relevant to them, so they could appear multiple bars. And so the height of the bar, but also the proportion of the bar that's a darker color. The darkest color represents high applicability, the lighter shade is moderate, and then the lightest is low. So as you can see here, it's quite obvious that there's strengths in project development. We've got a lot of companies, and we've also got a significant proportion of companies that are dark. Also, there are strengths, in ancillary equipment supply, vessels and marine logistics. And you can see where there are gaps are where there are little to no bars, blade supply, cable supply, and in decommissioning. So just to summarize, as I mentioned, for offshore wind, there are major strengths in Atlantic Canada in engineering, environmental monitoring, permitting, and project management, with many of these capabilities directly supporting marine industrial activities. There's substantial steel and secondary steel component fabrication capabilities, and there are local companies that can fabricate large steel components, also large concrete components, which can also be used in offshore wind. There's a strong presence in marine logistics and vessel services, as well as offshore installation and maintenance experience. Gaps, as I mentioned, the major gap that was identified here is there's a lack of major manufacturing operations or serial production facilities. So that basically shows that currently there is not a capacity to do serial manufacturing like you would need for an offshore wind farm. Often, 70 plus, 100 plus wind turbines being installed at a time. There's also a gap in companies capable of decommissioning, but we think this is basically just due to the infancy of the industry and companies not claiming or demonstrating capabilities in this sector. But based on the strengths in the installation categories, we feel that this will come with time. And then finally, for this slide, if you could look at the top right, we've got the distribution of high applicability companies across the 4 Atlantic Canadian provinces. And of note here is just there's a good broad distribution across all provinces. Most of the companies are located next to population centers in major cities and are coastal, which is what you would expect given the amount of coastline in Atlantic Canada. Okay, moving on. We also carried out a RAG assessment, or red, amber, green assessment for all of the different project packages in order to really assess the opportunity here. And we did this for offshore wind and onshore wind. 4 shows the strength of the opportunity being the strongest. 1 is the weakest opportunity. And essentially the categories that we've listed here, strength of existing capabilities, that's the ability of the region, Atlantic Canada, to perform the activities in each of these packages already. Demand case considers the demand for products and services, given available domestic supply, the competitor environment, incentive implications, et cetera. So looking at the local demand primarily. Investment case considers the level of investment and market confidence needed to transition supply chain and infrastructure capabilities for the offshore wind supply chain. Opportunity for export supply, that again looks at demand, but it's looking at external demand. So is there an opportunity to export this product or service globally? And it also considers the logistics aspect of that. And then, of course, potential for partnerships and collaborations, considers the degree to which partnership formation and collaboration could impact supply chain development, as well as the ability of the region to attract external partners. Okay, so that was a mouthful, but we like using these tables because it shows, excuse me, the strength of a particular category or package at a visual level. If it's mostly green, it's a strong opportunity. So if we look at project development, which is where we had a number of strengths, there are a lot of companies that can perform these tasks, and they have familiarity with local geography, local permitting requirements, the local work culture. They're well connected. And we think that this regional expertise will make it easier to attract outside partners. A lot of the developers would be doing the project development work, but they'd be seeking to contract out a lot of that work as well. And having that local knowledge would provide an opportunity for local engineering firms, survey companies, et cetera, to really share their knowledge. This would establish, local companies as suppliers and partners. For the manufacturing and component supply, while we don't have major manufacturing operations or anything similar, we do have a very robust base of tier 2 and 3 support, specifically in secondary steel, major industrial electrical equipment, custom monitoring and control systems. Now, this is a particularly high CapEx sector to get into. Manufacturing requires a lot of upfront costs, so you'd need to have a very strong project pipeline to justify any investment. But there is a very strong export opportunity. We're going to go into some demand scenarios, later, where you'll see that there is a very strong demand for offshore wind components, the potential for bottlenecks down the road. So basically, the presence of strong supporting companies in tier 2 and tier 3 could attract a major manufacturer to the region if there was sufficient pipeline. Looking at construction, transportation, installation, and commissioning, the region is well suited to marine industrial operations, as I mentioned, due to the history in offshore oil and gas, the shipbuilding, fisheries, all the ocean-going activity that we see. So we think that minimal investment is required here. Our ports are well developed, especially compared to a lot of other places where they have offshore wind ambitions. A lot of our ports are already supporting projects in the Northeast United States as they're getting built out. So we think that there are significant opportunities here for partnership to build track record for local companies that just need that little bit of extra experience in this industry specifically to get contracts. For operations and maintenance, there are very strong crossover opportunities from offshore oil and gas, again, with the region's well-developed ports and marine industrial experience. There are limited export opportunities here because it is something that's typically required to be close to site, but there is a strong potential for partnership, again, to leverage that local knowledge and experience. With regards to decommissioning, there is a limited demand for decommissioning right now, but this will grow with time, as I mentioned. And sector support, the sector support opportunity in Atlantic Canada is very strong, and targeted investment can help address existing supply chain gaps by identifying needs, directing funds, and ensuring that training programs align with industry timelines. Okay, so now we're going to go back to the onshore wind results. So very similar distribution here as we saw for offshore wind with regards to our bar chart. We assess the same base of companies and we assess them for applicability in offshore and onshore wind separately. So there could be a few companies swapped around, but mostly we expected to see a similar distribution. Strengths here include project management, or project development, engineering, environmental monitoring, permitting, project management, just like previous, but a lot of companies here have direct industry experience. Newfoundland and Labrador are slightly behind the other provinces due to previous moratorium on wind energy development, but there is a significant amount of onshore wind that's already been built out in Atlantic Canada. So we do have a supply chain that's quite strong, but as you'll see through the rest of this presentation, the scale of the build out for onshore wind will result in a significant growth in demand for supply chain for onshore wind. Again, secondary steel and ancillary equipment is another strength, as well as onshore construction, logistics, and installation activities. And we did note 23 independent companies that are suppliers of major industrial electrical equipment, such as control systems, transformers, and switchgear, as well as some smaller industrial electrical equipment providers. And I'll just note that items like transformers and cables are facing a backlog right now. So these are already seeing supply chain bottlenecks. Again, the weaknesses include not having manufacturing capabilities. Specifically, there are no identified support companies for blade and cable supply, and a lack of decommissioning. However, given the strengths in onshore construction and logistics, again, we don't think that's an issue. It's more of a representation. And same distribution of companies as we saw in offshore wind, coastal, and around population centers. For the onshore wind opportunity assessment or RAG assessment, we found that the region is well positioned to become a key supplier with minimal additional investment in project development. There are local developers in the region. I would imagine that given the plans for development, there will be more locating in the region as time goes on, and with the base of experience that already exists here. the region is really poised to succeed and, like I said, become a key supplier. For manufacturing and component supply, there is significant demand for turbine and balance of plant components, but there are cost pressures for long travel distances, given vessel day rates and fuel prices, which may make it less attractive to manufacture products for export here. But I will state there's sufficient local demand in onshore wind right now to justify investment, provided investors have confidence in the current timelines and capacities despite the really high upfront costs. We're looking at 34.5 gigawatts of onshore wind development in Atlantic Canada in the next 10 to 15 years based on current plans. That is significant. So 34.5 gigawatts, if you compare it to, say, Muskrat Falls, the hydroelectric project, that's less than 1 gigawatt. So that, just providing that as context. For construction, transportation, installation, and commissioning, the investment case here is strong. There is lots of local experience, and this is an opportunity for outside firms to partner with local companies to benefit from that experience. The O&M base, there are going to be a number of O&M bases set up locally. They need to be in close proximity to the project site, and it's a cost advantage to the developer or OEM for the maintenance team to be local. This is what we call low-hanging fruit. So it's beneficial to local companies and beneficial to the operators / developers to have local teams here. Decommissioning, there will be a major preference for local suppliers when the time comes. This will be sooner than for offshore wind, given there's already onshore wind projects that are getting up in years. So whether or not they'll be repowered or have their components upgraded to a higher capacity machine is to be seen, but there will definitely be a major preference for local suppliers here. And again, for sector support, there needs to be some scaling in their ability to support the development of the industry, just given the sheer volume of projects that are on the books right now. So one other thing we looked at when we were assessing the supply chain is supply chain diversity. We looked at women-owned, visual minority-owned, Indigenous-owned, 2S LGBTQ+, and disabled-owned companies to the best we were able to based on their self-reporting. And we were able to draw some conclusions based on that. So on balance, diverse-owned companies in Atlantic Canada have a stronger alignment with onshore wind than offshore. And this is partially because there is no offshore wind industry yet. However, we do find that offshore oil and gas, the supply chain there's less representation for diverse-owned companies than in onshore wind. Onshore wind has a very strong history of partnership and equity ownership with Indigenous communities in Atlantic Canada. So that really strengthens those efforts. Most diverse-owned companies show strengths in workforce development and sector support services like HR, training, capacity building, those types of things. But we have identified a number of companies in this diverse-owned category with major strengths in environmental services, permitting, project management, and management support. We also note that the majority of the businesses in this data set are small and medium-sized enterprises and micro businesses, which can lead to challenges due to capacity and funds availability. So when I mentioned earlier that there are some arduous qualification procedures and onboarding procedures, this is one area that can be difficult for small businesses and micro businesses to access due to internal capacity. And often a lot of these companies don't have dedicated websites, which makes it difficult to identify and analyze them. So as I mentioned, our company assessment was primarily carried out through desktop research. So companies that did not have websites were less likely to be included because we weren't able to assess their abilities. So this presented a challenge, as well as companies that weren't identified in the data that we had as being diverse owned. And I'll note that it is quite common in offshore wind right now, less so in onshore wind, but for offshore wind, particularly in the United States, for developers to be required to submit supplier diversity plans with their offtake solicitations. So when they bid to win a contract, they are required to discuss how they plan to increase diversity in their supply chain. So this is something that's a real focus in the offshore wind industry as it grows. With regards to Indigenous partnership and equity ownership, so I mentioned that there's been some really great examples of collaboration between Indigenous groups and companies and the renewables industry in Atlantic Canada. So strong track record in onshore wind. There's been significant financing awarded through the Canadian Infrastructure Bank's Indigenous Equity Initiative, and up to 5 billion, and I believe this was recently increased to 10 billion of financing through the Canadian Indigenous Loan Guarantee Program, which basically provides a backstop for financing for resource development projects, which, you know, is really a step up so that these Indigenous organizations can get equity stakes in these projects as they go. So within this framework of strengthened legal obligations, the Atlantic Canadian Indigenous organizations are looking to increase their participation in future energy projects on two fronts. So through project equity participation, as I just mentioned, and then also through supply chain participation through benefits agreements. And this is something that you'll see across all different resource projects, these benefits agreements. Okay, so I'm going to hand it back to Grace now, and she's going to go over the results of our opportunity assessment. So just so everyone's aware, in addition to the desktop research we carried out on companies, we also did some very substantial stakeholder and rights holder engagement, where we met with groups from right across Atlantic Canada, and we used the outcome of those discussions as well as our desktop research and literature review to come up with the following. So Grace, I'll hand it back to you.
Yes, thanks, Delia. So yeah, as Delia mentioned, these points here have been gathered, developed, and compiled through a combination of engagement and some analysis. And let's walk through the strength and opportunity first. And by the way, this SWOT applies to offshore, onshore, or both, and also relevant to all or individual Atlantic provinces. So we noticed that we in the Atlantic Canada has a world-class wind speeds, both for offshore and onshore, and have already attracted a significant developer attention. There is a growing track record of experience leveraging port infrastructure, not only for storage and laydown, but also for assembly and maintenance of offshore wind. From adjacent industries like offshore oil and gas, shipbuilding, civil construction, manufacturing, structural handling, we can have a transferable skills. We do have a strong network of assisting workforce development institution with potential to develop offshore and onshore wind training programs, and that includes courses and some certifications. There is established pathways for Indigenous economic opportunities on renewable energy and infrastructure projects. We also see there is a positive market signal from offshore objectives in Nova Scotia, and also early leadership from industry organizations like MRC, Marine Renewable Canada, Net Zero Atlantic, or Energy NL. We identify that there is a potential for local partnership with global suppliers, which is very great to build capacity and enable diversity initiatives. We find that retired or underused OG infrastructure can be repurposed for wind development. It is also apparent that opportunity for universities and research and development clusters can drive innovation in offshore and onshore wind technology research areas. It is also evident adjacent industry workforce that is familiar with offshore marine industrial operations. There is ecosystem of technology-focused innovation in autonomous system, advanced 3D printing, digital twins, etc. And later in this presentation, Delia will show you some recommendations in regard to this technology-focused innovation. And last but not least, there is opportunity for regional collaboration around best practices in permitting process, diverse workforce engagement, and local supply chain incentives. Next slide, please. Now, these weaknesses and threats, we separated into 4 categories: supply chain, workforce, policy leadership and communication, and innovation. We will run through all of that today, but if you like to see more detail, please go ahead and read our final report. It's free in the MRC website. So we noticed there is a global bottlenecks in workforce and equipment availability, which are straining multiple simultaneous projects, especially for critical infrastructure like transmission and distribution components, such as transformers and cables. Right now, there is no local manufacturing base for major components. Port and transportation infrastructure, including bridges, require upgrades to accommodate shipments, both onshore and offshore wind components. We also see the high cost of doing business in Canada, including steep federal duties on temporarily imported vessels, and that put pressure on project economics. There is stakeholder skepticism and resistance, which are rising in areas targeted for large-scale, rapid wind development rollout, often fueled by perception of inadequate communication and engagement. Excuse me. There is the absence of formal local content mandates, which creates uncertainty about the feasibility and clarity of local benefits, complex and burdensome procurement system, along with demanding certification requirements from top-tier suppliers, which can discourage local suppliers from participating. I think most of this topic has been touched base on previous slides by Delia. In terms of workforce, we see there is a labor shortages in critical roles such as technicians, electricians, and grid engineers. It's compounded by many things, but including aging local population and limitation within existing apprenticeship system. We also see provincial level bottlenecks in workforce and equipment availability across multiple overlapping projects. With regards to the policy, leadership, and communication, there is a community resistance driven by not in my backyard attitudes and environmental concerns, including impacts on fisheries, especially in regards to offshore wind, question about community benefits, and concerns over the recyclability of components, for example, blades. We do see the unclear pathways to market as transmission system and electricity export opportunities remain limited. There's also economics uncertainties, the absence of consistent project pipeline and unclear regulatory framework, which are dampening investor confidence in the wind energy sector. There is a global competition from regions with a well-established wind supply chain and stricter local content policy. There's also regional competition among local Atlantic provinces, which create inefficiencies and missed opportunities for collaboration alongside disparities in labor market and infrastructure readiness between provinces. Lastly, in policy leadership and communication related, there is an inter-provincial trade barriers limit, which limit the ability of provinces to support each other through shared supply chain and workforce resources. And in terms of innovation, we see that the current costs and inflationary pressure may limit investment in innovation or research and development space. So again, if you're interested to see more of these details, please refer to our final report. Go back to Delia.
Thanks again, Grace. Yeah, so Grace mentioned this is detailed more in our report. We've also mapped the weaknesses and threats, which we've identified as risks in our report, to the various recommendations that I'm going to be presenting now. So we've presented our recommendations in the same categories as Grace just presented for the weaknesses and threats. So supply chain, workforce, policy, communication and leadership, and innovation. And we're going to start with supply chain. So as I mentioned, there are 25 recommendations in total. So I'll just go through each of them and give a little bit of context and explanation. These are all explained in further detail in our report and assign short, medium, and long-term time horizons for when they should be completed. We've also made recommendations on who should carry out the recommendations and if they are applicable to onshore, offshore, or both. So if you see on the right here, one of the exercises that we carried out as part of this study is we came up with development scenarios to try and quantify component, workforce, and port demand for both offshore and onshore wind. We didn't look at ports for onshore wind. And basically the low scenario would be domestic use, so electricity generated for domestic use or for the grid. Medium would be electricity generated for domestic use plus export. We consider to the Northeast United States primarily as an export market. And then high would be the first two scenarios plus wind energy development for hydrogen as well. So there's quite a broad range, and what we're trying to do is determine a range of demand that we could lean on. And we looked out to 2050. So on the top here, you can see annual component demand with the turbine demand maxing out around, over 50 per year. And then the associated other components that are required there. And then you can see down below for onshore wind in the high scenario, wind turbine demand goes above 1,000 in 2027, and then again above 900 in 2033. So this is these are quite high demand numbers with regards to component supply. So just keep that in mind as we go through the recommendations. So the first theme in supply chain is leveraging existing supply chain strengths. So the first recommendation is creating long-term value in supply chain investments by focusing early investment on building long-term services that leverage existing experience and support sustainable growth and that have lower costs of entry. So services like legal, financial, environmental, engineering, and then other professional services that are required to get a project off the ground. You can't get a project built if you can't get it financed. You can't get it built if you can't get it insured. So these types of services are critical. And then also prioritizing timely infrastructure investment in marshaling and O&M ports. So, increasing crane capacity and other lifting equipment or SPMTs, and getting those ports ready to receive shipments of onshore components, getting them ready to do marshaling for offshore components. Recommendation number 2 is a longer term recommendation where we recommend exploring manufacturing to encourage supply chain clustering. So one thing that we did mention is that we do have a strong supporting ecosystem of tier 2 and 3 companies. And supply chain clustering essentially is a phenomenon we observe when a manufacturer locates to a region and other companies that are supportive, tier 2, tier 3 also locate to that region, and you end up developing basically a hub or a cluster of activity, which builds in efficiencies due to the close physical proximity of all these supporting companies. Or you can also see a manufacturing company or another major operation locating to a region where there's an existing support base of tier 2 and 3 companies. So remember, I noted that a lot of the companies that we assessed were clustered in various regions. That could make a good case for attracting manufacturing investment. So here we said explore opportunities to establish manufacturing operations and co-locate supply chain activity. Basically, it's important to develop a business case, make sure that adequate return on investment can be achieved with the project pipeline and timelines. So basically, the need to develop a realistic and properly timed strategy to attract manufacturing activities, given a sufficient project pipeline. The second theme here is strengthening wind industry ecosystem support. So this recommendation 3, streamlined supply chain development program, is something we've observed in other jurisdictions that's worked really well. Essentially, local content or contracting local companies, investing in the local economy is a requirement for projects to different degrees. Primarily in offshore wind, but also for larger onshore wind projects. And we've seen that it's a lot easier for major companies to contract with the local business community when they are aware of or have somebody facilitating or streamlining those connections, because they have a lot of things on their plate. They're not really able to take the time or resources to fully vet the local business community. So developing a supply chain program to identify and promote local companies' capabilities and mitigate barriers to entering the offshore onshore wind supply chains is really quite helpful. So at a minimum, this would be a searchable supply chain database of local companies vetted for their capabilities and their diverse or Indigenous ownership status. So Marine Renewables Canada already has a great database like this that's searchable for offshore wind. So we'd like to see something similar for onshore wind be developed. And then these types of organizations can use these lists and this local knowledge to do things like hosting or facilitating meet the buyer events or connecting developers with local companies to fit whatever need it is that they're needing right now. So they could be looking at fuel provision services. So then that organization could supply a list of all the fuel providers in the region, just for instance. Recommendation 4 is promoting and assisting rural businesses. So again, this is almost in the diverse business category, but these are the companies that are not concentrated in those population centers. A lot of onshore wind projects in particular are going to be located in rural environments. So it's important to increase awareness of opportunities and understanding of supply chain requirements for companies that are rural. So this would include establishing virtual engagement tools to overcome geographic barriers and allow entry of rural companies into the supply chain through effective communication with rural municipalities, EDOs, and chambers of commerce so that they know what the opportunities are and can help their constituents. Next, we've got recommendations related to supply chain diversity. So with regards to encouraging supply chain diversity, it's important to establish and communicate industry diversity expectations. So this is basically setting benchmarks and measurable goals for developers and their subcontracts. And this is something you would see in a supplier diversity plan. If you can't track it, you can't manage it. So setting benchmarks and goals is a really great opportunity to improve performance here. And then also establishing grants and subsidies to support diverse-owned businesses in those scaling, retooling, and upskilling challenges that we previously mentioned. Again, with establishing an entity that would take responsibility for this, we see in Massachusetts, where I'm currently located. By the way, I'm living in Massachusetts, but I'm originally from St. John's, Newfoundland and Labrador, just a point of information. And I'll be moving back home this summer. So in Massachusetts, they have a supplier diversity office that tracks all the diverse owned companies. It establishes where they're located, collects some information about their operations, and then provides that free of cost to anybody that's looking. And it also provides services to help promote local diverse owned businesses. So something like that could guide supplier diversity policies and also establish a certification process so that companies can have something to show that, yes, I am a diverse owned company and I have this to prove it. We also recommended that larger scale projects, and we picked 500 megawatts as our measuring stick here, to require developers to include supplier diversity plans in their licensing or offtake procurement project processes. And that would mandate engagement with diverse suppliers during early project phases. So this is, again, just very, very much leaning into that supplier diversity plan process that we've seen implemented in so many places. With regards to supporting Indigenous involvement in the supply chain, it's very important to educate developers on Indigenous equity options. There are some local developers that are doing really well, that are very familiar with a lot of this, but any developer that is not familiar with working in Canada will likely need a bit of education here. This will help to identify best practices for Indigenous equity options, and educate developers in tier ones on the different structures that are available, the benefits that come along with equity partnerships, and as well as ensuring that there is cultural alignment and that they're aware of Indigenous engagement and business practices, as well as the consultation process. And then 9, creating an Indigenous supply chain hub. We did struggle to find Indigenous owned company databases. So assisting with partnership building for smaller or less experienced Indigenous supply chain companies by building a consortium with industry players across Indigenous groups. This will also help by establishing a single point of contact for developers to limit engagement fatigue, which is something that's been observed in the industries. All right. Oops. Back one. Workforce. Okay, so these graphs there on the right, these again are from our development scenarios looking at workforce demand for the high scenarios. And in onshore wind, we've got high 1 and high 2. High 2 is what we're showing there. This is the build out of projects as they are currently planned. Basically for all of the Atlantic Canadian provinces out to about 2035, we have really good visibility of project planning. And in high 1, what we did is we tried to limit the development in Newfoundland and Labrador, who are developing 28.4 gigawatts of onshore wind for green hydrogen, to 2 gigawatts per year to kind of try and smooth demand. So you'll see that in the report, but here is the high 2 scenario. This is the actual currently existing timelines. And the way we quantified the workforce demand here is we grouped job roles that would essentially be in the same category, require roughly the same amount of training, and be focusing on similar tasks. So as a result, we have building trade workers, maritime trade workers, business professionals, STEM professionals, manufacturing trade workers, and support staff. So the highest workforce demand occurs during component manufacturing, as you might imagine. So that's the yellow bar that you can see here across the timeline. And even if we don't have any manufacturing, then you can still see that there's major demand for workforce, in the tens of thousands for onshore wind. So quite significant demand for workers. So as a result, we will need to strengthen workforce support structures. So committing to coordination between training entities, basically streamlining the region's wind energy training programs, making sure they share information, that they develop complementary programs, as opposed to, competing for resources. And then industry-funded training programs. This is a recommendation that would see formalized partnerships between developers and OEMs and training institutions. A lot of this training is proprietary within, especially for the turbine OEMs. So having these partnerships will help develop specific training that will lead to jobs, and will reduce the burden on the training institutions, especially with regards to getting actual components to train on. Improving access to training and workforce development. We've got community career opportunity outreach. So encouraging organizations to highlight career paths in the wind energy field, target hard to reach communities, and get in at the K-12 level. This is basically a communications and messaging campaign. The timeline for development of an offshore wind project is around 10 years. So a lot of the people that'll be working in the offshore wind industry in Canada will be in the K-12 system right now. We also mentioned the apprenticeship initiative or issues with apprenticeship. So strengthening apprenticeship initiatives is a key recommendation. Again, this would be longer term, and right now it's a little bit nebulous. But basically working on this in the long term to ensure that apprentices can transition into long-term employment following journeyman person designation. And then finally, connecting workers with jobs in the wind industry. Adjacent industry workforce attraction looks at creating upskilling initiatives to allow workers to transition from offshore oil and gas, construction, mining, and other relevant sectors to help meet the bottleneck challenges for concurrent development within both offshore and onshore wind by creating supplementary opportunities for the region's existing workforce. Not trying to poach workers, but making sure that they have overall increased employability. With regards to policy, one of the major issues facing the industry is looking at pathways for offtake. There's a low electricity demand in Atlantic Canada for domestic use. So exploring and firming other offtake pathways for markets in, like I said, the US Northeast, other Canadian provinces, green fuels like green hydrogen, sustainable aviation fuel, and corporate PPAs to help fully capitalize on the wind energy industry or opportunity. Setting capacity targets for wind energy development. And this is under the theme of sending positive market signals for regional wind energy development. So establishing and communicating these goals is a really good way of showing investors that you have confidence in the industry and that you've got a robust long-term development pipeline. Establishing transparent and predictable licensing, permitting, and offtake processes. Nova Scotia is going to be launching its first licensing round this year, but it's still unclear what the permitting and offtake processes are going to look like. So getting developers and the supply chain familiar with this will go a long way to clearing up some of that uncertainty. Establishing an investable value of offshore wind. Basically, we have had regional assessments carried out in Nova Scotia and Newfoundland, but this would basically revolve around developing a high quality wind resource database to be able to communicate the value of the offshore wind resource. So that would be taking that regional assessment one more step. Exploring reductions in the cost of doing business. So looking at ways to remove interprovincial trade barriers and unlock economies of scale and transferability of workforce, including revisiting the federal duty on temporary imported vessels and finalizing federal tax incentives. And this one in particular, number 19, I know the new Carney administration is focusing on this as well. And a number of the items that we mentioned in the report are actually called out by this new administration. And then finally, policy support for local economic benefits. This one is a recommendation we got from one of our stakeholder interviews where licensing funds would be directly invested in some of those early investment activities that we mentioned, like transmission and infrastructure, workforce upskilling, and then any other early industry work. And you can see just at the bottom here, these are traces of the development scenarios that we established for offshore and onshore wind. The high scenario for offshore wind goes to about 11.5 gigawatts of total capacity, whereas for onshore wind, we're looking at about 45 gigawatts total capacity. All right, just a few more left. We're on 21 out of 25. So with regards to leadership and communication, it's important to build industry awareness and support. There have been issues with public pushback or entities stating that they aren't fully aware of the local economic benefits. So here we recommend a public wind industry educational campaign, launching regional energy literacy initiatives to inform, engage, educate, and involve communities, Indigenous communities, and businesses. It's really important to engage as early as possible to communicate development strategies and, more importantly, to build community input. It's critical to listen to your stakeholders and right holders, not just tick a box when it comes to engagement. These people will help you develop the best possible project, and you will also be gaining social license to operate by meaningfully engaging with them. And then create supply chain development momentum. This one is Also, so important, interprovincial collaboration on wind. We have a lot of land, we have a lot of resource in Atlantic Canada. We don't have that many people. So compared to other jurisdictions, it may seem like we have less to offer, which is not at all true. But by developing a unified approach to marketing, investment attraction, and supply chain development, we'll be able to present the region as a cohesive unit and strengthen its value proposition on the global scale. So essentially, not only will we be capitalizing on efficiencies by avoiding competition, but we'll be creating an opportunity that's greater than the sum of its parts on the global scale. And finally, innovation recommendations. Atlantic Canada has a wealth of training and R&D entities. We're really known for ocean research, ice research, cutting edge technology. So these are really related to how we can capitalize on that. Innovation for the next generation of wind tech. So leveraging this existing R&D ecosystem by doing things like, looking at hydrogen production, harsh weather design for wind turbines, floating offshore wind technology. Right now, floating offshore wind is in its infancy, and I don't know if there's even one commercial scale. There might be one commercial scale project out there, but for the most part, they're smaller scale, and there's no dominant floating substructure technology. So you can see there on the bottom left, the W2 power concept. So this is an opportunity for our R&D institutions. Number 24 is carbon footprint management, or I could say just environmental management for the supply chain. Grace mentioned the recyclability of blades being contentious. So encouraging R&D to reduce these environmental impacts for things like extending the lifespan, using natural fiber composites and bio-based resins in the blades, advanced coating, alternative fuels, improved recyclability of components. These are all things that there's good opportunity for. And then finally, develop 3D printing to support wind industry technologies. You can see the UNB, marine additive manufacturing. I know there are other companies that work in this space as well in Atlantic Canada. So developing advanced 3D printing technology to supply custom, hard to procure replacement parts for the offshore and onshore wind sectors, which is modeled on the offshore oil and gas industry. So it will save money and reduce reliance on imports. So that could be a really great position for the region. Okay, so those are all the recommendations. I'm just going to conclude by summarizing everything we discussed, and then we'll go back to taking some questions. All right. So the region is very well suited to support offshore wind growth and expand on onshore wind through existing and potential supply chain. So overall, very strong. Stakeholder and rights holder engagement and inclusion is key to supply chain building and industry success. Workforce shortages and supply chain bottlenecks may limit development if not properly managed, and that's the key there. Planning and collaboration will limit this risk. Minimal infrastructure investment is required, given port readiness. Onshore infrastructure improvements are required for component transfer. So this is a significant strength in the region and just highlighting where initial investment needs to go. There's an opportunity to capture more revenue and create more jobs through regional manufacturing investment. And I'll note there that there's also a sufficient pipeline right now to justify this if all projects go to plan. And finally, positive market signaling is needed to build confidence in the project pipeline to unlock investment. And this can be done through target and milestone setting, as well as through government and developer commitments. Okay, and as if you have any specific questions for anybody that I introduced at the beginning, here's the contact information. The presentation will be available from Marine Renewables Canada, so you'll be able to get all of this after. And we will go into Q&A mode. So I'm going to stop sharing just so I can see what's going on. So thank you, everybody. And we're happy to take your questions.
I can certainly, again, thank you, Delia and Grace. And I can certainly go through the questions for you, pose them. I know Grace, thank you, answered a few of them live, which is great. So we'll go with the ones that are remaining. the first one is easy. I actually can answer that. And they were asking if people would be able to obtain a copy of this and the materials. And as Delia said, yes, we'll send an email to everybody after the webinar with a link to the recording and the slides. So the first one is that approximately 34 megawatts of offshore entirely dependent on hydrogen development, which has feasibility challenges and may not come to fruition due to markets and technology.
Yes, so 34 gigawatts right now is slated for green hydrogen projects. So while there are questions around some of those projects and the hydrogen market in general, there are other options as well. And I think somebody asked a little bit later on what some of those could be with regards to, corporate PPAs and that type of thing. But yeah, that is currently what is slated for green hydrogen support. Yeah, huge capacity.
Thank you. Another question. What could trigger offshore wind in this region? To what extent offshore wind could be more interesting in this area in competition with onshore wind?
So basically, well, Nova Scotia is actively developing offshore wind. They're going to do a solicitation this year. They've set a target of 5 gigawatts of leased seabed capacity. So this is a great example of how to stimulate development in a region. The other provinces, Newfoundland and Labrador remain open to the opportunity. However, very focused on onshore wind right now, given we've just come off of the wind energy moratorium. There's a lot of crown land to be developed and a lot of interest in green hydrogen. With regards to how can we develop offshore wind, I think that once so there's a number of ways to answer that. The cost needs to come down. Right now, onshore wind is significantly cheaper than offshore wind, just given the logistics that are required to install an offshore wind farm, the size of the components, the workforce requirements. But as has been seen with onshore wind, as industries grow and develop and economies of scale are realized, costs will come down. So there may be a time when this is less of a difference in cost, in which case offshore wind would be a lot more attractive. Otherwise, you do see fatigue with developing onshore wind. So once a certain threshold has been reached, or you're running out of developable land onshore, then you would switch to offshore. So you see this in the Northeast United States because there are major population centers with electricity demands that are coastal, and there is no land available around to do onshore wind. So they're forced to go offshore in those cases. So I guess the short answer would be when the costs come down or when there are less other options for development. That'd be when you would see offshore wind coming online more prominently.
Perfect. Thanks. We have two more here. Any thoughts on Canada's potential opportunities in sustainable data centers in Atlantic Canada and more broadly across Canada? And then there's two other follow-up questions. Are we competitive when compared to major energy parks and corridors in the US? And what would attract a hyperscaler like Microsoft, Google, Amazon, et cetera, to build in Canada?
Great questions. So essentially, what is really attractive about Atlantic Canada is the strength of our wind energy resource. We have world-class wind speeds, which means if you put the same wind turbine in Atlantic Canada as you put, elsewhere in the world, we will generate more electricity. That also means that the cost per kilowatt hour is less expensive. So that is a really strong, feather in our hat as a region with regards to attracting, especially, things like data centers or a corporate PPA where they're, using the energy on site. We do not have sufficient transmission infrastructure to develop all the offshore or onshore wind that we want and use it or transmit it. So that's a limitation. But in terms of establishing operations locally that require a lot of electricity, I think that would be an easier undertaking. And you'd be able to, still would need some grid upgrades, but I think it'd be an easier project to execute on, just like hydrogen generation is really localized. So I think that the region would be very competitive with regards to that, especially, given the temperatures that we often see in Atlantic Canada are a bit cooler, and these data centers require significant cooling and water for cooling as well. So I do think that could be an opportunity for the region, and that we would be very competitive with regards to other jurisdictions, just purely based on the strength of the resource, available land, and available water. I'm not sure if I addressed all the follow-ups there. I don't see the question. Hold on,
You
something.
did here. Let me look.
There we
The
go.
follow-ups were, are we competitive when compared to major energy parks and quarters in the US, and what would attract hyperscalers? So yeah, I think you did.
Yeah, I think so. And I mean, with
Yeah.
onshore wind especially, you can get costs down quite low, especially if you build in economies of scale. So yeah, I would argue that we are quite competitive.
There's one other question here, and I don't know if you can answer this because there was a lot that you looked into. So great presentation. Are you able to share which databases you use for supply chain analysis? Which is a lot. Yeah.
They're all listed in the report.
Yeah.
Yeah, so I don't have it right in front of me now. But I mean, we started with Marine Renewables Canada database, and we were quite fortunate to have had a number of databases provided to us. We're also able to get some publicly available databases off the internet.
And it
So yeah,
started with all the industry associations essentially
yes, yeah, all
that
the
are
local
around.
industry
Yeah.
associations, construction associations, and a couple diverse business associations. So yeah, if you're interested in the full list, it's in the report. We were able to share the data with Marine Renewables Canada, but we aren't able to make the data public. That was part of the agreement we had with those folks sharing the databases. So apologies there.
Thank you. Another one came in. Did you find any potential synergies with other marine renewable industries?
That's a really interesting question. So we didn't investigate that as part of this study, but it's something that we do in our office and other parts of our work. I mean, there are lots of concepts to develop offshore wind plus solar, offshore wind plus tidal generation. Nothing is in a commercially ready state yet, but these are areas that are, seeing significant research and development work. And then also, I mean, it's not renewables, but there are initiatives taking place as well. I know in Maine in particular that are looking at co-locating offshore renewables like wind energy with aquaculture, so things like kelp or shellfish cultivation. And as well, there have been concept studies in Atlantic Canada looking at co-locating offshore wind with offshore oil and gas operations to help decarbonize those operations and provide electricity at site. This is something that we can see in practice in Norway. The Hywind project is floating offshore wind that's powering some of their offshore oil and gas operations as well. So not exactly in the same vein, but there's a lot of opportunities for these synergies and developments going forward. It's a really exciting time.
Okay. I don't see any other questions in the queue. I think we've gotten to them all, which is great. And yeah, we're just about at time. So I'll just say a few words sort of to wrap things up here. And I will say, if anybody has any other questions that come to you after we get off, or maybe once you have a look at the study, certainly reach out to us. If we can answer them, we will. If not, we will hand them off to Exodus and her team to have a look at as well. But as far as MRC's next steps to support this work, we're going to be focusing on the recommendations that we can play a role in delivering. We're going to continue leading our international business development trade missions. We do have one planned for June to Renewable UK Global Offshore Wind, which is in London. And it looks like we'll have pretty close to a full house of participating companies for that. If anybody is interested in attending that, please reach out sooner rather than later because we are almost full. We do currently have a plan to lead a mission to the American Clean Power Association conference and exhibition that's in Boston in October. We still are currently evaluating the feasibility of that now, just with everything that's happened. And we'll keep everybody up to date on it, but currently it's still in our plan. And then we are also organizing what we expect to be a fairly large Canadian delegation to Wind Europe next year, which is in spring in Madrid, I believe. We're going to continue with our market intelligence supply chain webinars. And of course, the supply chain database, which we've mentioned before. If you're a Canadian company, you can be part of and entered into that database. There is no charge. Any Canadian company can be included in that. So I encourage you to go to the MRC website. You'll find a link that'll allow you to sign up. And then, of course, our conference is coming up. I'll put the little slide up here. In November, our annual conference. It's going to be November 12th to 14th in Halifax at the Halifax Convention Center. So we have outgrown hotels and we have now moved to the Convention Center, which also gives us much more space to work with. So we're expanding this year's conference. We're going to have a very large exhibition component now that we have the space to do so. And we also will have concurrent R&D and technical sessions running, and there's a call for abstracts out now. We're going to be extending that deadline to June 16th. Deadline was originally May 16th, but we have the time. So if anybody's interested in submitting an abstract for that R&D technical stream, please do so. And for members of ours, we're also have a call out for member workshops. So the day before the conference, the 12th, which is the first day, we run some member-only sessions and a member-only networking event. And we're always looking for members to present to other members about educational, interesting topics. So you have the ability to submit workshop proposals for that as well. So I encourage you to check out the website or reach out to us if you have any questions on that. So I'd like to, I'll close things out. I just want to thank Delia and Grace again. Delia and Grace have both done this a whole bunch of times over the last 2 weeks. So we appreciate you doing this yet again for us for a webinar. I want to thank everybody for attending. We really appreciate you giving us your time and our project funders. Like I said, stay tuned for more information, some more webinars, and some more market intelligence that we'll be sending out in the coming weeks. Thank you again, everybody, and have a great afternoon.
Thanks so much.